Hello, and welcome to our session on modern data on Azure. My name is Sean Bice. I'm the Director of Program Management. I work on a number of data services on our platform. So you've heard a lot of great things today about the Azure platform, ranging from SQL Database to SQL Data Warehouse to Data Lake to Cortana Analytics. There's a ton of great things. Today, we're really going to double click and focus just on the data platform. Now, when you think about modernizing your app using our data services, what I really want to do first is just introduce you to some of the frameworks that we think about. First, we all know that there's transformation happening in the industry. Basically, every industry is transforming almost every day. Education is better, manufacturing is better, healthcare is better. Why? Data is basically at the center of all of this. Now, if you want to really embrace data and be a data-centric company and build data-centric applications, we really believe that you want to have a consistent data lifecycle behind it. What you see on the page here is how we think of a consistent data lifecycle, and it really breaks into three parts. If I expand those three parts, we really first think about capturing and managing data. Above that, we think of transforming that data. And then at the very top, we think around how do you allow just everyday users to visualize and ask data any question that comes to mind. Now, if you take a modern application, for example, or you take a ticketing application, you want to make it more modern. The first thing you're going to start with is a transactional workload. So there's a relational model somewhere in there where you're, for example, taking orders online and you want it to be predictable and fast. You might also, all of a sudden in an app, imagine if you ever purchased a ticket before, you might want to quickly add the ability to take feedback on an app or allow people to give ratings for a concert. You don't really want to drive that through a relational model, but you need to get that into your application quickly. This is where you might use something like DocDB. Now, as you expand the data sources that you have, it is really, really important to deliver some of the richest search experiences to help your customers find things as fast as they can, regardless of where that data is. This is where you might use our search service. And then finally, as you have all of this data ingesting into your systems, how do you make these applications smarter? How do you really discover actionable insights on all the data that you have? So today, let's go ahead and take a closer look at those four things that I just mentioned. The first thing I want to introduce is Tony Petrosian.
Hello.
Tony, so we have a Wingtips application, and this is our online ticketing app. So we know that we have challenges in a sense of, we're selling concert tickets. Some concerts are really popular, others are not. We really have no idea what the workload's going to look like, but you as a DBA or a data developer, you're trying to sort of provide the very best experience, minimizing the cost. How do you use SQL DB to help you with this?
All right. So we do have this ticketing application. It's a SaaS application where we provide services to people who want to sell concert tickets for their venues or events. Obviously, there are different size events, different size venues. You've got your Tuesday night poetry club, and you've got your mega concerts. And it's really difficult to predict how much bandwidth you're going to need for your transactions for each of these. And then it gets really complicated when you put them all together. So if you were to manage this all by yourself, you would have to manage a lot of databases, monitoring, load balancing, and it's really difficult to do. So what we have built with Azure SQL Database is the ability to manage a lot of databases with our elastic pool model. With elastic pools, you can put a lot of databases in a pool where you continue to have your isolation from security perspective, your resource management based on policies, and all of your administrative functions separated for each customer. But then the pool allows you to leverage all the resources collectively. So when you have venues which are not very busy, they could basically allow venues that are very busy to borrow some of the performance and get better performance, and allows you to burst basically.
I see. So basically, I'd love to take a look at this, but I think what you're just saying is, hey, I got thousands of data. I might start off with 1 or 10, hundreds, but eventually I have thousands of databases. We really don't know what the workload pressure is going to be. The last thing we want to do is create something that hurts our bottom line of the app.
That's right.
The next thing we want to avoid is sort of over provisioning an environment or under provisioning it. Next thing you know, our users just have a bad experience.
That's right. I mean, usually when people start, they have one or two databases. They get big databases because they want to have a good experience for their first few customers. But before you know it, you're successful. You have hundreds of databases, hundreds of customers, and then the numbers start to matter, right? You can't have over-provisioned databases for everything. It just doesn't make sense economically. So you want to have the ability to manage as a aggregate.
All right, so let's see SQL database.
So we have this app, and you can customize. Each customer has their own little web page. You can go buy tickets. You can find seats. And so we're going to buy a ticket here, purchase. And each of these customers that hosts their website gets their own database. So I'm just going to pop over to the Azure portal. And this is our SQL database page. I've got a bunch of icons set up so we can go quickly look. So first thing I'm going to look at is our server. So I have a server. It's got 39 databases because we have 39 customers. Each customer has their own database. They're numbered by customers. And one of the things that you first see is that right at the top, there's some recommendations. Well, the nice thing about Azure SQL DB is it has all this machine learning technology behind it, which takes a look at the telemetry and the usage patterns of the databases, and it comes up with recommendations of what would fit, what would be best modeled for you, and try to come up with the best fit for your databases as a group. So here we have a couple of suggestions. There are 7 databases that would fit in our basic Elastic pool, and you can go click and you'll see the databases. These are probably databases that don't see a lot of action, so they can easily fit in a basic pool. And the recommendation is to create a 100 DTU pool and put all of your databases in there so you can just click and take the recommendation.
I see. So at least I think what you're showing here is through some sort of machine learning, what's really happening is there's an evaluation of those singleton databases. You're getting a recommendation to fall into this basic pool. Okay, let's keep going.
So I have another recommendation for premium pools. You can go take these databases. So assume you have some of your more larger customers that really put a lot of pressure on the databases. So the system has kind of figured out that there are some databases that require a lot more resources, and they might be a better fit for a pool which is of the premium type, where you can have a lot bigger burst capability.
Got it.
And with this, you can then categorize your customers. You can have your bronze, silver, and gold customers. You can put your gold customers in your premium pool. Your bronze customers can go in your basic pool, and you can manage this in totality and watch the budget as you go.
I see.
So I have a pool that I have created for our standard customers. Think of this as your silver customers. The pool has a number of databases in there, and I'm going to just talk about a few of the elements of this pool. The first thing that you see about a pool, that it has a list of databases in there. So I can see my databases, and these are several databases. There's 6 of them in there. The pool has a set of characteristics, which basically defines how much resources the collective gets. So the entire pool gets 200 DTU. That's our transaction throughput unit for Azure SQL database. So that's very nice. You set of policies for your pool. But the real nice thing about it is you can also set policies for the individual databases, because you don't want to just take a bunch of databases and throw them in a pool and let it fight with each other, because that noisy neighbor problem could be really complicated. Yeah. So the pool allows you to define a minimum guarantee of resources for each database, so that the pool ensures that no matter what's happening, the database are getting the minimum that they need to survive. You can also set policies for how far they can burst. So some pools you can allow the bursting to happen because this is your mega concert pool. So you can allow the individual databases to burst much higher than some other pool that you have for lower tier. So this is all of the elements of the pool. And here we can see I've got a bunch of workloads running here, and you get all these nice reports about what's going on in your pool. So right now, not much is happening. The pool in aggregate is about 17% utilization on its CPU and about 19% utilization on its DTU. And you can go change the sizes of your pool. You can reset the policies for each of the databases and manage this as you see fit.
Great. So this just takes the guesswork out of, I'm a developer, we've got an online application, we have no idea what the workloads are really going to look like. I don't have to over provision. I don't have to under provision.
That's right.
Instead, I can take these databases, I can put them in a pool group. And then once in a pool group, basically the concept I need to know is how far do I want these databases to burst? And what's the minimum CPU guarantee I want to have?
That's right. And then you just look at your pool in totality. So if you have some pools that are pushing 90% all the time, then you just go bump up the pool size. Now, the nice thing is whenever you move things in and out of pool or change the pool size, your databases stay online and then you can continue to use them. There's no taking down databases to move them around or load balancing. All of that is done online. So you just go make your decision, you make your changes, you take the recommendation that the system gives you to improve your situation, and then the system takes care of it.
Got it. So speaking of recommendations, so here's the next one for you. So now that I have databases running in these pool groups, good news. For a developer, there's no more guesswork. And if I can set a minimum and then a maximum bursting level, but that's not database performance in its entirety.
No.
Like, we both know that.
That's right.
So now let's say the scenario is we have hundreds to thousands of databases. We know a key way to increase database performance is with the use of indexes.
That's right.
But going through schema by schema by schema and trying to decide where best to place an index, I suppose you could do that if you wanted to. But clearly with all this giant corpus of databases in Azure, is there a way for machine learning to sort of help with that?
Absolutely. I mean, creating the right set of indices is the most important thing that you have to do to optimize your database, to ensure you're getting basically the best efficiency out of the database. If you have too many indices, you're going to impact your writes. If you don't have enough indices, your workload is going to be, and it's really difficult to figure it out for one database, let alone for a collection of databases. So what we have here is, I'm going to go look at a database. Again, we have telemetry that is looking at the database usage and what the databases are doing with respect to performance. And again, we have some machine learning algorithms that continuously monitor and try to figure out how best to optimize this particular database. And in this case, we have this thing called an index advisor, which basically comes up with recommendations for your indices. What indexes should you build to make your workload be more efficient? So the system provides you some recommendation, and then it tries to figure out what the impact of this index would be. So here we have 4 recommendations. One of them is low impact, 2 of them are high impact, and the third one is medium impact. And the system is basically telling you, if you were to build an index, you would really improve your performance. Now, you could basically say, you know what, I trust the system, I'm going to take your recommendation. You click on this recommendation, and off you go, and you create the index. Or you can say, hey, you know what, I don't want to see it. So show me the scripts for this index and how I would build it and what it would do, and I'll take it into consideration. Yeah,
so this is actually pretty remarkable. And I love this. If you kind of go back to the blade, if we look at this here together, so in the past, we would have literally gone through schema after schema after schema, really trying to define where are the best places that to put an index in for it to make an impact. But in this case, Azure is basically using its machine learning, as you were saying.
That's right.
To sort of make these recommendations. I think what you just showed, though, we should just take one more look at. I mean, this is great. You see a recommendation here, and you're saying, I literally, if I trust the system, I can just click a button and then the index will get created for me?
That's right.
Oh, wow.
You can just say create index and the index will be created
and then,
for your
And
workload.
then if I don't trust the system, really this ability to see the script is, hey, I can take the script that effectively Azure would go apply for me, I can go apply myself.
That's right.
That's
so
awesome.
The nice thing is lots of people have production systems, test systems.
Yeah.
So you get the same set of recommendations on your test system that you would on your production system. So you could actually go and say, hey, you know what? I'll take the recommendation on my test system. If I like it, then I'll take the recommendation on my production systems. Yeah. The other nice thing about this is usually people take a look at the schema and try to do the mathematics necessary to figure out what indices to build in absence of the workload. Here, in this case, the workload is happening because these databases are under use. So it is really the recommendation is not just based on the schema, but also what's happening to the database. Yeah,
which, I mean, it really leads to this third point we wanted to take a look at on SQL database. So, one of the best parts of Azure is having millions of databases and millions of workloads. arguably it's emitting more telemetry than software has ever seen before. Now you're just taking advantage of this telemetry to make sense of both the schema and how the workload is. But if you look at security, everybody's worried about security and from a variety of dimensions. And I know security isn't one thing per se, or one feature equals security. It's really about a layered approach. It could be auditing, it could be data masking, it could be always encrypted. It has to do with processes that in your own data centers. But if you think of our application that we're looking at right now, data masking is actually really important. Why? Because we're constantly hiring employees to come through. They could look at a customer record. I don't want to go do a giant app change, but I would love to be able to data mask the right columns in my databases so that at least when a sales agent is in looking at a customer record, we could mask, for example, a bunch of characters of a social security number, a credit card, et cetera. So how hard is it to do data masking in Azure DB?
So in Azure DB, it's really easy. We have these, again, I'm going to go into our database blade, and there's a lot of elements here. Well, like one of them is you can go turn on alerts, you can have auditing, but you also have dynamic data masking. So if you go into your dynamic data masking blade, again, based on the database and the columns, the system will provide you some recommendations for data masking. Now, because the system is working with millions of databases, it is well trained on a lot of data, not just one database's data. Yep. So in this case, we have some credit card numbers, some customer names and emails, and this is based on the actual database that we were looking at, right?
Yeah.
So basically here, there's a recommendation that we should create a mask for the email address of customers and last name. And I'm just gonna go ahead and create one. And you can see that it provided a mask function automatically for this column, which says, hey, awesome. It's an email, so I'm going to keep the first letter of the email address, and I'm going to keep the .com, but I'm going to get rid of the rest of it in X amount. And I simply just save this. I can also just go say, you know what, I'm going to take the credit card number recommendation, and I'm also going to go take a look, and I want to just see what else I can do. So if you don't want to take a recommendation, then you can go browse your schemas, you can go browse your tables and pick columns that you want and apply masking function. And we provide a bunch of masking function for you so that you can actually use the functions that come with it. Here, I'm just going to save, and it's going to go apply these masking functions to the database. And the database is now going to have this. I'm actually going to pop in here and take a look. I've got a couple of databases that have masking turned on. So here is a query I'm going to run. This is a database before the mask, and you can see that the email addresses just show up.
I can just read it. Yeah.
Yeah. And if I go to a mask database, you'll see that the email addresses are now masked, so are the social credit card numbers, and you can apply various masks.
Yeah.
And it's really nice because it's based on credentials, so the set of users are excluded who have to see the real data, but most people are masked. So in this case, it's not just about masking the data in an application. I'm connecting to the database directly from management tool. So even the DBA, if they're not in the right group, they won't be able to see data.
That's an interesting little trick you just did there. We went from the portal in the system giving recommendations, which is awesome. It's all about speed. There's no friction. As a developer, great. Help me identify the columns that should be masked. Take the recommendation off you go. What you actually just did, though, is switch to Management Studio outside of the portal, and we connected directly to the database with the mask. So that's awesome, Tony. Thanks for your time, and it's great to see the progress with SQL Database.
Thanks a lot.
Yep. So welcome back. Now let's take a look at how we can use Azure Document DB, or DocDB in short, in our application. And with me is John McIntyre. So John, one of the things that we've heard from customers is they just want a better customer experience. We're like, hey, of course, what does that really mean? And so, the whole purchasing tickets online, it's fast, it's efficient, the transactions are going through, as we looked at with Tony. Feels good. But one of the things that we've heard is when people are coming in to buy tickets, when you're looking at the stadium chart or whatnot, you'd love to know what the guy or gal before you thought about that seat. before you buy the ticket. Last thing we want to do is actually drive that through this giant schema change and through a relational model, et cetera. But how can we use DocDB?
Yeah, absolutely. I mean, it's a great scenario. In fact, as we see customers on Azure, we see them building these fan engagement platforms and services and experiences. And a lot of them are fed by this semi-structured data, lots of data being collected, lots of data being presented. And I think, DocumentDB is a really great service for this type of use case because, what DocumentDB does, it allows you to ingest all of that data. You can have applications that create that data. And as that data is written to the database, all of that data is indexed. So, we have this semi-structured data, but at the same time, we have a up-to-date index. And what that allows you to do is query over that data and deliver some great experiences on top of the data. And like you said, Sean, I mean, this isn't necessarily the right fit for a transaction processing system or relational database. And, we talk about what we need to build here. I think the requirements, if I heard them correctly, are we don't exactly know what we want. Yep. We know it needs to scale. And when do you say we need it? Yesterday?
Yeah, exactly.
So
let's see it.
Tony told me pretty clearly, I don't get to touch the transaction processing system. So I think DocumentDB is a great service that we can bootstrap one of these apps, we can get it going, we can iterate, and we can deliver some great fan experiences. So why don't we do that? Why don't we just jump right in, use DocumentDB, and see what we can get built here today.
Enhance the app. Let's do it.
Great. So for those new to DocumentDB, we'll start in the Azure portal. The first thing that you need to do is create a DocumentDB account. From the Azure portal, you click on the New button. Excuse me, DocumentDB is under Data and Storage with our other database offerings. So let me just zoom in here. There you see DocumentDB. You would create an account. Once you've created that account, you're really all set to go. At that point, you just can start writing JSON data into this. That data will be indexed, and you can start to build application experiences on top of it. Fortunately, this isn't the first time I've done one of these database account things, and so I have one ready to go. So I'm going to open the database account blade. The first thing you'll see in the database account blade are a set of tools. I'll just zoom into the top there. We have a Document Explorer. Document Explorer allows you to peek inside the database, look at all those JSON files. If I want to modify those JSON files, I can do that from Document Explorer. Query Explorer allows me to query over that data. So I have a rich set of SQL query capabilities that are provided by DocumentDB. And finally, Script Explorer is something new, or fairly new. We added this capability to allow you to create and manage your JavaScript code that's executed inside the database. So some of these use cases might be, I have some application logic that I actually want to run close to the database for performance reasons, or I maybe want to transact multiple documents at the same time, and DocumentDB allows you to do that over that JSON data. So those are a powerful set of capabilities.
No, it sounds great. And I mean, we'll go about this for real. I actually don't know what the schema should be. I mean, I honestly have no idea. We want to show folks like this really happens. I know we need a better experience. I have no idea what the schema should be. So how do we start capturing feedback from our customers?
And you're right. I mean, this is we're going to iterate, and we're going to iterate on both the experiences and the data model and the schema. And DocumentDB is a fantastic data service to allow me to do that. So what I've done is I've actually imported some of our event data. I've done that using the data migration tool. If you click on the import data, you can see details on how to do that. But I could easily operationalize this through our data movement services like Data Factory. So I could create Data Factory if I want to move my event data from my relational store and copy it into this semi-structured store so that I can query over it. And you'll see some of the fan experiences and rating and review experiences that we can deliver by virtue of that. So let's just query for some of that. You'll excuse me while I jump into Notepad here. Let's grab some queries. So the first thing I'm going to do is just a good old select star. So we're going to run this select star query over our corpus of event data. So this is all the event data that was in our transaction processing system. We've pulled it in, we've denormalized it so that these applications can now just grab the aggregate document. They don't have to join anything to get that event data. They can pull it down and they can render it for users and event goers to take a look at. So We have the artist and we have the venue. We have that as a hierarchical document. So you have this denormalized view of the data. And we have that for all of our events. Because this data is indexed, I can actually query over any property in that document. So here you can see I'm doing where type equals event. So I'm looking for our JSON documents where type equals event. Let's run another query. Here I'm actually doing a projection of the data. So maybe my application doesn't need all of the data, or maybe it needs to be shaped in a specific way because it's being bound to a UI control or something. I can reshape that data. I can actually materialize JSON as part of the query processing pipeline. So I can do a lot of interesting things there. And here again, I can order that based on any of the properties in the data. And then the other interesting aspect of DocumentDB is it actually natively understands geospatial data. So if you include any valid GeoJSON in a document, and so let's run this query and see what GeoJSON actually looks like. And here we're just doing a projection, similar projection, but let's actually do a select star. Let's call an audible here. Do a select star. And here I have that GeoJSON, that location data that I've highlighted. That's valid GeoJSON per the GeoJSON spec. As that comes into the database says, hey, location data, I'm going to index that. And now you can do things like proximity queries. Here I'm doing a proximity query to find venues that are within 2 kilometers of the Seattle Space Needle.
So that's pretty awesome. So the flexibility here, I mean, this is very different than if we were working. The nice thing about data is that it's coming in all shapes, forms, and sizes. And, in some sense with the transactional system, you don't want anything. The day you get a phone call from your bank and they tell you hey, our bad, but your account is off. It's like unacceptable. Yeah. But in this particular case, just looking at all this flexibility kind of goes to show the new behavior around as we're shaping schema here on the fly.
Absolutely. So let's move over to a coding experience, and I'm going to jump into VS Code. Now, we both said we're not exactly sure what we want, but I took the liberty of just throwing together a really simple Node app. So this is a mobile web app, so we'll render it into a browser. And so the intent is here, let's give some concert goers an experience on their phone where they can go and they can provide feedback on the event, either the event that they're going to or event that they've gone to in the past. So let me just hit F5 here. Again, this is just a simple Node.js app, and I'm in Visual Studio Code here. So I'll hit F5, and we'll run this. And then let's load it up in our mobile browser over here. So here we're doing a very similar query that we did in the portal. We're doing a proximity query. So I'm getting all of the events that are around me, and I'm getting all of the events in the past. I am shaping that data as it comes back so I can bind it to the control that's actually rendering it. And I can go in and, I went to this concert a few weeks ago, and so let's go in and give a review for that. It was one of those places where, you got to walk forever to get some food and get a beer. And so, I have to say that, it's a total downer. I mean, you get back and you have cold food, and you have warm beer, cold food, nothing worse.
Yeah, nothing worse.
So let's just say food was cold. Let's give that feedback so people know things about that venue when they're buying tickets there. Now, if we were to go back into the document store, so let's go back into our Query Explorer, and let's change this and look for those comments. Just grab my queries here. So let's look for a comment that we just inserted. First name's John, item type or document type is comment. We can run that query. And then so that's the data that we just inserted. We have our comment text, we got our user ID, first name, last name, so I can render that. I have the time at which it was created. So now if we want to start rendering that data either on the main site or through the mobile site, we can do that. We can build an experience that's appropriate for that form factor. So I think we have the beginnings of a good fan engagement experience.
Yeah, no, I mean that's actually really cool. We just, believe it or not, within just a few minutes here, we shaped up. Yeah. We didn't design a schema on whiteboard. Yeah. We're sort of shaped it up. Now we can take ratings. But look, if I'm using, I don't have my phone on me, but if I'm using my phone, I really don't have the time to type in, long walk, whatever. But oftentimes I do have the time to sort of give rating, let it be 1 star, 4 star, 5 star. at least for people that I know are truly paying attention to the feedback,
Yeah.
they're at least going to get a rating from me. So can we add ratings to this?
For sure. Let's do it. So let's go back to the app. Let's shut down the app here. We'll pull up some of the source files, and let's start from the experience forward. So first thing we're going to do is we're going to just add a control, a ratings control. I have some commented code here. Let me just do a quick search. Oops. Close that. So let me just uncomment some of this HTML code here. So here I have a control that's a ratings control. There's lots of them out there. I can just grab one. I can embed it in the front end. And then I'll update the corresponding JavaScript code so that I include that rating control. This was something that I anticipated a little bit. So we have some of the code stubbed out because, hey, what's feedback without ratings?
Mm-hmm.
So we're going to grab the ratings when someone submits the button or the button submit event happens. We'll populate a variable called ratings. And then the last thing we need to do is actually send that rating via post to our comments route that's in our Node.js app. So basically what we've said is we've shaped our experience from the front end. That's changed the data model.
Yep.
We're now pushing that data to the back end of the app. So we'll update the comments route. The comments route will then grab that rating. And then here you see, I'll highlight this. This is our document. This is what we're writing to the database. And so we're just going to uncomment one of these properties, which is ratings. And so that's going to add that data to that document. The other thing that I have stubbed out here that I think might be interesting is for people to really, and maybe this is more interesting for people running events and in particular for large venues, but maybe we can grab the location where people are actually submitting their reviews from or where people are doing ratings.
Totally makes sense in the context of our scenario here.
So people are who have opted into that functionality will grab their location. So let's save all these changes. Again, so you'll notice, like, we haven't touched the database. We haven't modified the schema. We haven't specified secondary indexes. We haven't given any schema hints. I mean, we're living the code first dream.
Mm-hmm.
And so let's see, we'll run that application now. We'll go back and we'll reload this. So let's go into another one. There we have our ratings control.
Awesome.
We can give feedback. Great show. Let's give that 5 stars. And that gets submitted to the back end.
Yeah.
And then just to complete it, if we go back and we look and we run that query, we can see both the ratings and the location now showing up in those documents. Those documents are commingled with other documents that don't necessarily have the same schema. And so in a lot of cases, this can allow you to do things like, I may have different apps running at different versions of apps running deployed at the same time in mobile experiences, and those apps can understand the properties that are relevant to those experiences.
Yeah, and I think this is a great sort of closing point on DocDB. It's what we're really looking at here is we've taken an app, we're using SQL DB for the things we discussed before around predictability and recommendations around indices. Can never let a transaction go wrong. But now we're just coupling another Azure data service, in this case, to build a better customer experience. Now we just saw these two things work together with a lot of ease. So hey, appreciate your time, John. So welcome back. So now let's take a look at how we can use Azure Search to search the number of data services that we're using behind our app. Joining me here is Pablo. So Pablo,
hey, Sean.
The application that we have is, Tony helped us take a look at how to use a relational model and make it more predictable with pools and auto indexing, et cetera. And then with John, we were just looking at, how can we build a better customer experience as fast as possible? We didn't even really know what the scheme was. It worked out great. But now that I have basically two different data services powering my application, I really, how do we really get an immersive search experience where you can get after all the data that we have for our customers?
Right, makes sense. Yeah, that's natural. Once you have a working app, search is this natural way to interact with applications that all of our users expect. So we created Azure Search to make sure that as you're building your app on Azure, you have a simple answer to the question of how do I add great search experiences in my app.
Yep.
So I have the copy of the app here. So to add search to it, we'll do three things. We need to create a search service to provision some search capacity. Then we'll create an index and hook up the index with the one or more data sources we may have. And then finally, we'll hook up the application with the search index so we can actually search. So let's start there. So here's the app, and here I'm in the Azure portal, and I have some of the components of the application. So first thing you do when you want to create a new search service is you go to New, search is in Data and Storage, and then you'll see search there, and you can configure your subscription, which region in the world you want your service to be deployed. You can pick multiple regions, and also what pricing tier you want to pick. In this case, I have one already created. Let's go to that one. Once you have a service, you can also tune things, like, how much capacity you want. This is a dynamic thing, so as your workload changes, you can change capacity as well. And you can also manage indexes and manage data sources. So what we're going to do now is that we have a service is we're going to create an index and connect the index to one or more of the data sources that we have.
Got it.
So here in the portal, I'm going to go into import data. And first thing I do is I need to choose a data source. We support a couple of data sources that we handle completely automatically for you. And if that model doesn't work for you, or your data is somewhere else, maybe it's on premises in some other server, you can also push data into us using an API. So you have either choice. In this case, I'm going to say connect to data. I can do SQL or DocumentDB. You can see that we're really well integrated into the rest of the system. For example, here, if I say DocumentDB, I can browse, and now I'm browsing my DocumentDB accounts. If I pick a particular DocDB account, here I have all the databases, and when I pick a database, I can see all the sessions, all the collections. So a very easy way. You don't have to discover anything to connect to data sources. Similarly with SQL, we grab a connection string here, and I'm going to call this demo data source. Once I have the data source pointing at my database, I can see all the tables and views. In this case, I'm going to pick a view that I already have and say, OK. So now we pointed Azure Search to the database and to the particular view. We're going to inspect it and then propose a schema for an index. I'm going to call this index concerts. And I'm going to tell the system that the key is this ID. And now I can choose all sorts of options that make it possible to then do interesting things on the search side. So I can say simple things like whether some fields are retrievable. I may want to say this field, this kind of control information, I don't want to hear, so remove it. Maybe these things are filterable. Maybe these things are good facets, so I can get hit counts and things like that. So let's pick a few of those. And finally, what do I want to be searchable? So I'll say the full title is searchable.
So let me ask you a question here. So I think all of us at some point have actually not had a great search experience. And you know it right away, right? You type in something, and within a second, this isn't good. So how important is what we just looked at for developer, to get this right? I mean, are the words "get it just right"? But how important is what we just looked at here to get searching right?
This is key in terms of you want to have a rich search experience, and users have many expectations about that. Web search engines and many of the popular e-commerce sites and things like that have trained users to expect great building blocks for navigation, like faceted search with hit counts on the side, very fast iteration, so you can tweak something and search again, great ranking, and solid linguistics as well, where the search engine really understands what you're typing. And by telling us this information, we can do a lot of that for you.
Yeah, and what's interesting here, what you just said, this to me is actually an incredible amount of power in a sense of what you said earlier. There's a lot of folks, their whole experience in looking for things, it's search, search, search.
That's right.
And it's not browse, browse, browse. And just looking at how quickly we could sort of organize the search of what you can really do to make it impactful and meaningful for customers, it's pretty awesome.
Yeah. So let me give you one or two more examples of these. So once I have this configured, I can actually drill a little deeper. And if you want, you can just start with this. This will give you very good search out of the box, but you can tune a little further. Like, for example, you can choose for each one of the searchable fields, you can tell us more about the language. And this is an area where our customers told us it was important for them to have great support across many languages because their applications get deployed internationally. So what we did is we took technology from Office and Bing. These are many, many years of baking in very high-end natural language processing stacks. These are the things that are used in things like the Word Grammar backend or Bing. And we incorporated them here so you can use them. So we support 50 languages right now. For each of them, we have pretty deep understanding on what's going on. And I can simply go here and still by default, I can pick one of the Lucene, this industry, well-known industry stack for search, or we can pick one of the Microsoft ones. So for example, in this case, I can say I want the Microsoft English Analyzer. And you can pick from a whole bunch of them. And by saying that, we'll do things like we'll understand inflected forms of words and things that you don't want to spend your time on. You want us to take care of it.
Yeah, no, if there's a set of assets behind it in Azure and Office as your dictionaries and whatnot, I don't want to go fiddle around with that.
That's
if
right.
I can pick it, that's fantastic. It just saves me time.
Yep. So one last thing I want to do here is I'll set up a suggester. We'll get back to this later, but I'll say the sources for suggestion is going to be the title, and we'll close the loop on this a little later. So great. So now I've connected to my data source, and now I started with the template scheme I was given and customized the index a little bit. Last step is I'm going to create an indexer. I'm going to call it demo IX. The indexer, think of it as the thing that connects the data source with the scheme, with the index. And I can have many of them. Maybe I have one for DuckDB and one for SQL, all pointing at the same index or at different indexes. And I can give it a policy like, do I want it running once or maybe hourly or daily? Or you can also set up more fine-grained things. And we'll do incremental updates. So you can say, in this case, for example, we can discover which field would be a good high watermark. Or in SQL Server, if you have integrated change tracking enabled, we'll automatically work with SQL Server and discover deltas. Similarly, with DocumentDB, we know how timestamps show up there, so we'll automatically integrate for you. Great, so we have this set up. I'm going to commit this change. And now when I hit OK, what's going to happen is we'll create all the building blocks for you and stitch them together. So we'll create an index, we'll create an indexer on the data source, connect them together, create a schedule for them so you never have to worry about this again, and then run it for the first time. So we populate it with whatever data is today there. So if I go here to the portal, you see I have a concert index now. And if I go here to the indexers, I can see my new indexer showing up here. And when I look at the details, I can see it ran once. Over time, you can see execution history here. Since this is a set it up and forget it, none of your code needs to handle this. So we give you a management experience. So if something happens, you can see here what's going on.
Yep.
Cool. So now that we have all the building blocks, the last step, we've created the service, set up indexes and data sources. Last step is to actually search.
Yeah.
So let's do some of that. First, let me start on the geeky side. I'm going to just hit the API directly so you can get a feel of that, and then we can see what it looks like to do this in the app. To hit the API directly, I'm going to use a generic HTTP client. This is Postman. And you can see here, this is my service name, .search.windows.net. This is the concerts index. So if I hit search on that, I didn't have a search criteria, so I just get a bunch of documents. It's a simple JSON response. And I can add here the search parameter, and I can search for something that is interesting. For example, I'm going to search for hall, and then I get those that match the particular search criteria. Since there is actual search, you get a score. There are multiple of them. You can see differences in score and so on. So searching itself is piece of cake. It's just a simple HTTP get on an endpoint, and then you get the results in JSON.
And off you go.
Yep. Exactly. So last step now, let's hook this up into the app. So the first step is to hook up the search portion. So if I go here to search and I search for, say, hall, which was searched, then immediately we get a response. We know this is in English, so we'll do obviously simple search, but in this case, I told the system it's in English. We'll tolerate difference in singular, plural. In other languages, there's more variation in things like gender and number and inflection, verbs in a million tenses and so on. So we know all that and we'll handle it.
Yeah. No, well, looking at that search, so the nice thing is we created the service, created an index, we hooked it into the app, and I'm searching and I'm finding something pretty quick, the right thing pretty quickly. But honestly, when I start to search, if I go to Bing or what have you, I start to type, and I actually wait.
Oh, fair.
Right?
Type and wait a little bit.
I don't type the whole thing anymore because somebody else has done it already.
Got it. Yeah. So that we call that suggestions, and there is for autocomplete. So I can do something here when I start typing a few words, and then immediately we get suggestions for you that are based on the information we have. We take that information, build a suggestions index as well, and then propose you suggestions right away here while you're typing. And then once you're ready to commit on one of the changes, then you hit enter and then you do the actual search. Looking at the code for what it takes to build these two capabilities, so search and suggestions, on top of what we just built. During initialization, you simply create. We have, in this case, I'm using .NET, so I'm using the .NET SDK. Use a first-class client. You configure once. You can choose to do all the steps I did in the portal. You can also do them programmatically. You can see them here happening at initialization time.
I see.
Usually, when you're building an app for the first time, you do the portal. When you want to automate deployment and so on, you do it here. Yep. And then let's look at the code that backs that page, the controller for the search portion and the suggest portion. So on the search side, you can see that all we do is we take the search parameter, and then we go to the search client, which is part of the API, and simply call search async. We pass the text that was input by the user, and we'll do everything else. We'll go execute the search, do the ranking, apply all the linguistics, all of that, and give you a set of results that will display in the UI. For suggestions, remember that we created a suggester before as part of the portal flow. Yep. So again, you take the partial text that you can pick up as the user is typing, and there are great JavaScript components that will do this for you if you don't want to do it yourself.
Right.
And you're calling at real time. The user is typing, you're calling as real time, and will immediately find the set of candidates. And you can see here, we get the partial input, the suggester, and we'll return the candidates for you. And in this case, one thing we also support that we're enabling is when people are typing, it's very common to make mistakes, and you don't want to get them out of context. Like all of a sudden, there's no suggestions because you mistype one letter.
Yeah, or you mistype a letter and all of a sudden you have nothing. Exactly. You're trying to help continue that along.
Exactly. So we'll tolerate mistakes simply by enabling fuzzy matching here.
So I don't, as a developer, I don't really need to do anything special here.
That's right. Like our goal is just with suggestions for each one of the typical scenarios where you need a search building block. We've provided APIs that cover all these building blocks. So you just focus on building a great search experience in your app and just call into Azure Search for all your search needs.
Yeah, Pablo, I appreciate your time. That's pretty awesome. Like we look at SQLDB and DocDB, and then we take a third Azure service, just wire in search. Then you have a pretty great experience in no time. Yeah. All right, thank you. So welcome back. Now let's take a look at Azure HD Insight, part of our overall Azure data lake, and see how we can extract value out of unstructured data in our system. So with me is Assad. So Assad, so we've had a really good run here, just modernizing an app with a set of different data services. So as you know, we started with Tony looking at relational. John walked us through DocDB for a better customer experience. And Pablo, we just looked at how we can search all this data. But for our business of wingtips or this application we're modernizing, we've got all of this data coming at us. And one of the things that we want to do is get insight out of it and action it. What we can't afford to do is have somebody reading, for example, as John was showing, a customer giving a rating. You want to have you want to use software to help us sort of interpret what's really going on, potentially have intelligence where we could direct if we were having sound trouble or seating trouble or food trouble somewhere. But the last thing we want to do is have people literally trying to make sense of all these data streams just so we can have a better customer experience. So how can we use HD Insight, for example, to help us in that sense?
Sure, Sean. So as you said, basically we started from the very structured data and then semi-structured, and now basically the area we are looking at is you have as you mentioned, comments, which is totally unstructured. Basically we don't know what people will type. But at the same time as we go and collect that data, we want to go and enable two things. One is we want to make it actionable in a very swift way. And the second is that we want to go and drive our business from that. So basically draw insights out of it, because although it is unstructured, we can do some magic with it so that we can still use the traditional BI tools and still look at it in a fashion where we can take action. So what I have over here is actually, as you mentioned, as part of the HD Insight clusters, I'm using a Spark cluster. And the way I built it is similarly as you saw with the previous, with Pablo and Tony, you go to the portal, you go and create a cluster. So I did that part with this one. And what I have opened is experience on top of the Spark cluster. And this is called notebooks. It's very popular these days. The ML folks, the machine learning folks use it a lot. And the reason it is very powerful is you can type it in, you can do a REPL loop and do all of that. So what I have is, and again, these are very flexible. You can even write your notes in here. So I covered the steps in here. So what I want to go and do is I will take the comments then that we collected in the document DB. I take all of that, then I take it from one location and train the model on top of it. So basically, the model is a multi-classification model. So basically, it takes the comment and it says, this comment is about seating, or this comment is about food. And once I have trained the model, then you throw in any comment on it, and the system will automatically tell you that what the comment is talking about.
I see. In terms of starting to categorize these comments for us. Got it.
Right.
Okay.
And then as the next step, what I will show is that these days volume matters. The more the volume of the data, the better it is. So basically, as a company, you should see how you can take advantage of it. So basically, I will take even a bigger set with like millions of rows of comments, and I will retrain the model, and you will see the advantages.
Yeah.
And then I will end it with opening the Power BI and going through it. So let's do it, all of it, in 10 minutes.
Okay.
So what I have is the model I'm using is the naive base. Like again, if people are not from the machine learning, they don't need to care. It is a classification model. And I take all of that data and I run and parse that data in here. And just for the debugging, I'm just printing the first 5. So basically, people are saying the seating arrangement was bad or the seats were not comfortable and things like that. Then what I do is that I tokenize all these comments, and then I define a vector for each of them. And in the end, I actually go and build a pipeline and train the model. So this actually at this point is going through every comment from one location and then training the model. Once that is done, I have a simple function where you go and give any comment and it will go and classify it for you automatically. So for example, let's type in something. So I can say, I will call this function. So I say classify comment, and in the string I can pass, like, let's say the food was cold, and I hit enter. It is saying that as per the categorization, this is for the food. But like that was pretty straightforward because of course it has the food name in it, right? So it's obvious. Like even if you had a if else statement or something like that, that would have got it. So let's type in something more interesting. So you say like there was a lot of echo in the back rows. Now, what I'm talking about is the sound system, but again, it doesn't say sound anywhere, and it is using the words which, unless the model is not rightly trained, it will not go and categorize it. So when I go and hit enter, now it's saying performer. Of course, it is close because like the echo is like, the machine learning model is a little confused that is it about the performer, or like what they are saying on the stage is creating the echo, or is it the sound system? But we know it is the sound system, right? If you look more closely. So where is the problem? The problem is at this point, my data set is not that large. So as a next step, what I will do is like, I will actually go and take millions of rows, not from this event, every other event, and then retrain the model on top of it. So I will quickly do it. And again, this is a Spark cluster. This is a very scale-out solution. I'm using a 20-node cluster. So basically, it has a lot of horsepower in there. So I will go in here and I will say, don't use the comments. So use the list which has the global list. And at that point, I will go and rerun this one. And again, now you will see other types of comments coming in, which is like the speaker is a sub-quality sound and all of that. I go and rerun this one. Again, vectorization. This will take just a few seconds because again, now the data set is much bigger. And now I again define the thing, and now let's rerun this one again. So now it categorizes it correctly. Now it is saying sound.
Yeah. So this is actually a very subtle point that you just sort of are working. Some folks may have no idea what training a model actually means.
Yeah.
And I think you just showed it in a very, very simple way, or the process of training a model where, you know, I never put feedback in. The sound was bad. It just, there was an echo. And in this case, as we added more and more data, this sort of really does say the more data that you have in Azure, the smarter your application's going to be. And in this particular case, we're just throwing a whole bunch of data, you're training the model, and now it knows it's a sound. It's categorized as sound.
Exactly. Like basically at some point, like how good the algorithm or the model is stops to matter. At that point, it is the size of the data. And that's
Yep.
the whole concept with data lake. Like you just keep storing data.
Yep.
And then there are systems like in Azure Insight and Hadoop and Spark and all that, they will make the best use of your data.
Got it.
So now what
Okay.
I will do is like, again, this is still too geeky, like a notebook, like if you are a business owner, you're like, yeah, whatever, like show me some high level picture, like what is my business doing, what is impacting, people are complaining about like sound or food, how does that impact my business? Like that is the key thing, right? Now we take the same unstructured data, now we go and connect through the BI tool and still go and extract the same traditional reporting that people are used from like traditional OLTP and other data warehousing technologies.
Yep.
So what I have here is I have the Power BI. So running in the browser, you go and hit powerbi.com. It's a free service. Now you go and you say get the services. You go in here. They have done an awesome job with building all these connectors.
Yep.
Now you go to the database and you will see the Azure Insight Spark right there. You
Yep.
go and hit that one and you go connect. The only thing it is asking is like, where is the server? The server is the same which I used in the previous example. So I just take this address and I type it in here. And I can also use advanced options. So I can say refresh my data. So basically I can set up an auto refresh in there. So I'm not doing that right now. I will just connect. So I will type in the username and the password and I hit connect. At this point, what actually it is doing is that it will go and connect to my Spark cluster and look at the unstructured data and the schema which I defined when I was defining the machine learning model and extract all that metadata. And then I can use that metadata to go and start building my reports. So this takes a second. As soon as this is back, I will go and start building the report.
Yeah. So basically, we're loading a data model now into Power BI.
Yep.
Right. And then once we get this data model loaded up, then we really could create whatever kind of canvas or visualizations of that data that we would like.
Right. And then behind the scene, what it does is actually it uses direct query. So there is no caching. So
I see.
basically, because the key thing with the large data set, and again, in the big data space is like, when I connect to Spark, I might be going against like 50 terabytes, a petabyte or something. So basically, if you go and try to do caching at any layer, whether it is the client, mid-tier, or anywhere in the server, then you can hit a problem because it's like the data size is so big. So let's go to this one. What I have is the Spark data set which I just connected.
Yep.
And the customer feedback you were looking at is this table, which is the customer feedback from 2015, and this is just from one of the this is one of the events which happened, or from this year, actually 2015. So now I will go and start dragging and dropping on the chart and start extracting the information out of it. So the first thing I will do is like I will say city and the comments which I got out of it. So over here it automatically picked the right charting for that, and it will go and show me the comments which are coming in from each location.
Yep.
So it already is looking at the size of the circles, like as people are aware, like I can get some sense. The second is I will go and build another chart. The second chart I will go and build is like I will say, and I can pick the chart. I can say, show me the category, and for each category, how much of the comments I'm getting. So one thing you will notice is that traditionally what people are used to is like these clicks and these drag and drops. Like if you are from the SQL, like you are very used to it. But if you are from like the Hadoop and the big data, like this is like you write the Hive query, you go for a coffee, you come back, the query is not done, you go back again, you come back, and you realize you typed the wrong thing. Like now the systems have become so interactive that actually each of them is a Spark SQL query over a big data set. But it is still interactive enough that I can use a BI tool.
Yep.
So let's create one more chart. So what I will do is that I will say, let's pick this one, and this time I will go and pick the city. I will pick the count, and I will pick the sentiment, and I will explain you in a second what I'm doing here. Let me make more space here. And I drop this one here. So over here, what I'm doing is right now is that I have built 3 charts, and actually I can also show you the comments which are coming in. So let me just put this one a little small. Put it at the bottom here, and just look at the comments in this one. So what I have here, and now let me make some space. So now I have a fancy report, and what it does is that now I can start asking interesting questions from it. So let's say what I do is that you see 3 charts. One is showing me the location where the event happened. The second is showing me where each category and how many comments I got. And the last one is showing me 3 things actually. It's showing me the location. The black line actually shows me the Twitter sentiments. So the only thing which I did not do in this demo is just like I categorized the comments, I was also categorizing the tweets which are coming in.
I see.
And for this, I used binary classification. So either the tweet is negative or it's positive. And the higher the black line is, that the positive tweets you were getting, and the dips are actually the dips in at that time when
yeah. So if we sort of look at a couple of dips here, you know, I mean, this really shows the value of Power. I love Power BI why? Because a picture is always worth a million words. At least I can see it, and then straight away I'm like, you know, what's there's a thing going on, and it looks like California, with seating, and I mean, just the.
Yeah. So basically, for example, if you are interested in seating, all you do is you click on this thing. The rest of the charts gets focused on the thing which you're focusing. And again, this is all unstructured data. This is like literally either JSON files or CSV files and plain text.
Yeah.
And from there, basically you are able to extract the information that, oh, you said seating. Let's go in. The seating is the issue. The biggest issue we had was in Los Angeles.
Yeah.
And that defines the first big dip we got in our social
I mean,
sentiments.
this kind of goes back to this model of, you know, people could be commenting, especially the amount of money people sometimes will pay for a concert.
Yeah.
You know, hey, I was uncomfortable.
Yeah.
And then as the volume of data comes in, then we can sort of, Azure, in this case, HD Insight, Spark can help you sort of put categories around that of like, hey, it's seating, and all this feedback coming in has to do with seating. So from our wingtip application we're selling concert tickets in this scenario all over the world, but at least this helps us. Could you imagine if you had to read through every single comment? It just doesn't. It's not going to scale. But in this sense, at least we could at least have some intelligence around, hey, we got a problem here,
right?
And then we go address it. This is a great example of embracing data to be more competitive.
Yeah, that's why, even if you go and look at the first comment, do not pick the seat number 20E. Otherwise, who can go and extract that information so that it becomes actionable, so you can go and fix whatever the problem is over there.
Yeah.
So basically, it's both making the data actionable, as well as a business owner, you can go and see when are you getting the most dip in your social sentiments?
Yep.
When people complain about the performance or the sound system or the seating or whatever. So basically,
well, speaking of which, I mean, it looks like the other dip here is, in concerts, the last thing you want is a dip in sound, right?
Yeah. So let's click on Seattle and see why we got the dip over here.
Yeah.
And it will go and it will refresh the charts. So as you can see, in Seattle, the biggest problems were sound, and that caused the dip. So basically, not only that, you know what the problem is, you also see the impact of it in the social sentiments, and there's a clear drop because of that.
Yeah, in the comments, I'm hearing an echo. The data model didn't know that meant sound, but once again, you train the model. Software is helping us analyze that, and then in the spirit of visualizing and being able to take action, we know in this case the venue here in Seattle, we really have a customer problem in the sense of what they can and can't hear.
Right. So basically, this is the machinery. So we build the app.
Yep.
Awesome. That is what customers are interacting. Behind the scene, this is where the fun happens, where you take all of the data being generated or what people are typing in, and then how you optimize your businesses so that you make more money out of it.
Thanks, Asad. So hopefully you really enjoyed your time with us. What we really wanted to do is show you how easily you can embrace these different data sources or different data services to build a more modern app. And as we really talked about in the beginning, there is transformation that's happening in all industries. And at the center of the transformation is data. And the real argument is those that are going to fully embrace data, as we saw today, are going to be more competitive and they're going to build more compelling apps. And with Azure, you can trust every data service that we introduce is going to work well together. It's going to be simple. Hopefully you saw the simplicity across the board. So I would invite you to come to the Azure portal. You can try out any data service. And hey, if there's any question that you have about data, feel free to email me directly. My email is Shawn, B-I-S-H-A-W-N, B as in boy, I, at Microsoft.com. So email me at ShawnBI@Microsoft.com and any data question you have, and I'll do my best to direct that to get it an answer back to you as fast as we can. Thanks for your time.
Thank you.